Yeah, then we start. My name is Inger. I'm leading the BA-Network, trying to spread knowledge and experience. And at the time, we have a lot of focus on tunnels and now railways. And I will wish Philippe and Joël a warm welcome. And you can now, time is yours.
Tusen takk, Inge. Tusen takk at vi får mulighet til å presentere våre tjenester og løsninger i regi av BA-Nettverket. Og velkommen til alle. Jeg er Joël Biedermann, daglig leder i Amberg Norge. Vi er et konsulentselskap som tilbyr tjenester i alle faser av underjordisk-prosjekter til både byggherre, entreprenører og konsulenter. Vi har bred erfaring og lang erfaring fra prosjekter både inn- og utland, og besitter unike kunnskaper om kompliserte grunnforhold og ulike drivemetoder. Amberg Norge representerer Amberg-gruppen siden 10 år i Norge, og gruppen består av 4 hovedavdelinger. Amberg Engineering, vi leverer prosjektering for underjordiske strukturer som jernbane, vei, T-bane, vannkraftanlegg, fjellrom og så videre. Det gjør vi å modellere modellbasert, i tillegg til bruk av innovative arbeidsmetoder som 4D, 5D og automatisert BIM-modellering. Den andre i gruppen er Amberg Logleg. De kombinerer moderne analyse og programvare for smarte løsninger innen byggeplass logistikk. Deretter kommer Amberg Technology. De er en av de ledende leverandører av avanserte systemer og løsninger for å samle inn og forvalte informasjon om infrastruktur. Og vi har Amberg VSH, som er Hagerbach testanlegg, som er et fullskala 5 km underjords tunnelanlegg med laboratorier, områder til produkttesting og trening i spesielle arbeidsmetoder. Det finnes også et eget restaurant og lokaler for forskjellige arrangementer i VSH, det er i Sveits. Tema til disse nettverkstreffene ligger hos Amberg Technologies. Og det er 3 tema som vi har utvalgt for disse BA-nettverktreffene. Så Amberg Tunnel, som dekker, Amberg Tunnel Surveying, Amberg Tunnel som dekker alle måloppgaver som er relatert til tunnel. For eksempel har de interessante løsninger for å spare på antall stikkere på byggeplassen. Dette blir et tema på nettverkstreff 7. april på Fornebu. Det andre tema her, det er geofysikk. Det er geofysikk med tunnelseismikkprediksjon, som vi bruker for å se grunnforholdet fram fra stuffen og fremover opp til 150 meter. Dette var tema siste uke, og det ligger opptak av det på YouTube-kanalen av BA-Nettverket. Og det siste tema her, som er dagens tema, det er Amberg Rail, som dekker alle måloppgaver som er sporrelatert. Og vi får høre mer om det av Philippe på engelsk. The floor is yours, Philippe.
Okay, perfect. Thank you very much. Welcome, everyone. Thank you very much, Inge. Thank you very much, Joël. I will share my display with you. Today, I'm going to present you I hope you can see what I can see.
All good.
I just quickly want to switch off my camera to save a little bit on the... Yes, here we are. Perfect. Welcome to Amberg Technologies. Today, like Joël mentioned, the topic is rail. Rail survey and track inspection tools from Amberg Survey, from Amberg Technologies. Amberg Rail is like better track performance, less maintenance, subsequently saving money. I'm going to show you a few applications which I believe in Norway are relevant for Norway. I'll dig right into it. Just to give you a quick background of Amberg Technologies, we were founded in 1966 by the senior Rudolf Amberg, now led by his son Felix Amberg. And you see we have about 20 years of history in track and track inspection, track maintenance works. Yeah. How does it look? What is our offering for the market in rail? Here we go. So let's look a bit. It's a bit how should I say it? It's the complex here that show, but I will go into each detail. We have two parts. We have actually our GRP, which is a track trolley, a track measurement system, which can perform various applications as survey, tamping applications, clearance, and inspections is good. We have a platform called Amberg Rail, which is the application where everything happens, the Holy Grail. We'll see what it is. And then that system called GRP-FX, a modular hardware measuring system. This is the way it looks. We'll go into more detail about the module. It's modular. Our hardware part is modular. It's scalable. You can upgrade it. And it's been proven for over 20 years. We have constantly innovated and adapted all the hardware components and firmware at the same time. On the other hand, we have Amberg Rail, like I mentioned. It is our software platform. Amberg Technology is predominantly a software company. Yes, we need some data providers, which in this case are our trolley, which all the sensors, plus total stations and GNSS from Leica Geosystems. We can exclusively only work with Leica Geosystems, means Leica total station will transfer the geodetic information directly to the trolley. So that's about the data providers. Back to software, we have a software called Amberg Rail, which has the various applications, and the various applications will result in various configuration of the trolley. Going quickly into these individual one. So Amberg Rail, we have tamping. Tamping, which is most probably one of the classic in Norway, not only Norway, but around the world. There are many, many thousand kilometers of tracks which are in ballasted tracks. Ballasted tracks need regular maintenance. So we have an application called tamping, Amberg tamping. It's for construction, for renewal, and maintaining ballasted track. The trolley will look approximately like this. We'll go a little bit in more detail of each of those applications. Then we have slab track. Classic slab track is used in the follow line tunnel. There normally in today's tunnel you don't put ballasted tracks because it's a bit difficult to maintain ballasted tracks in a confined space such as a tunnel. So therefore you tend today to go for slab track. Slab track, the big advantage is you don't need a lot of maintenance, except the rail head needs to be checked once in a while. Eventually you need to replace a rail, but basically a slab track doesn't need maintenance over several years. Yeah. So we have a slab track application for surveying, and of course to lay the tracks, and for maintenance work when you replace a track, a rail, for example. Typical configuration is our GRP 1000. We'll see that a bit later. The next would be inspection. Inspection, it's classic. It is for track geometry. Here, we only assess the track geometry. It is used to plan a new track or to assess a track when we don't have any information about the track. So it's classic inspection. We'll see that a bit later. Here, a very, very basic configuration. It looks basic. It's not as basic as it looks, but we'll come to that later. Then we have survey. This is classic 3D. Now we're talking in geodesy. We want to know, where does the track lie? Where are all the encroachments? Where is that pillar? Where is the bridge starting, etc., etc. So it's to plan and site preparation for example, for a track, for a tamping job, you want to do a survey before you then do the track, the survey, the tamping job. And last, but most complicated, that's typical configuration. And last is clearance. Now we're talking of series set of captors, of sensors. It's for mobile 3D scanning, documentation for BIM, clearance gauging, etc., etc. So that is basically the most heaviest, of course, and it is dedicated to clearance and measurements and mapping in tunnels or on the track, along the track. Now, going back to to measuring the platform, the multi-sensor platform. This is the base which is relevant for all configuration and all application. It's the trolley, which consists of a central sensor board, which is somewhere in here. You don't see it. It has an odometer, which is placed here, and it has a gauge measurement system, which is highly precise. The gauge goes plus minus 0.3 millimeter. And the next would be a cant sensor, which can do a cant super elevation of plus minus 10 degrees, which is relevant to plus minus 260 millimeter, at an accuracy of a static accuracy of 0.5 millimeter and kinematic of plus minus 1 millimeter. So this is the base of all configuration. All these sensors are always active and taken in consideration when you do any survey on the track. Now, we need to configure that a little bit. Oh, hang on. Of course, there's a battery system. Of course, everything needs to work independently. We can take the power from above. So many lines are diesel, tracks have no electrified. So yes, we have an integrated battery system. We'll come to that right away. Now, take, for example, we have several add-ons, a prism column, a profiler, total stations with automatic tri-block, a battery system for the various scanners. So we're talking scalability here. Depending on what kind of job you need to do, like for clearance, clearly a clearance, you can do it with a profiler. But if it's a long tunnel, you rather would go for scanners. And as I said, you need to be independent. So here we have a battery system which feeds these scanners and give an autonomy of approximately 8 hours. Next to that, to all these sensors, we also have so-called AMU, Amberg Inertial Measuring Unit. We'll see what will that add to the performance of the trolley. Again, you can configure in this part and you can add these onto the trolley when you need more performance. And of course, if you have tracks laying somewhere in the prairie and you have absolutely no control points, you have no idea where it is, you can use GNSS, of course, compromising on the accuracy, though at least you get a 3D, you get an information, where does this track lay in the prairie, yeah? And of course, just to complete, we have different wheels. We have also tram wheels. We have our trolleys are used in the city. The tram wheels, of course, can't have that kind of size because tram wheels are mostly embedded into the tarmac on the road. So we need smaller wheels. We have also, in this kind of wheels, we have stainless steel, typically used when you lay a slab track, because the rails are still rusty and the polyethylene wheels would wear off too quick. So we have a full set of all applications, if it's rail, if it's track, etc., etc. How does it work and how is that workflow? Just schematically, a small workflow. You have one computer, basically the same computer for everything. For the preparation, where you prepare your project. This preparation, you have several input features where you can input land XML, your alignments, your previously acquired data of the track, or the planning data, as if it's a new track, how does the track has to be laid, especially of course the slab track and baluster tracks. Once you have prepared everything, you move over and then you go from an office environment of a survey office environment, you go onto the track and you go into a survey mode on the very same computer. So we don't have to juggle data back and forth. The data is always on the same computer. And here we have a simplified graphical user interface. A user is guided through the setup of the product, of the trolley on the track. Considering the job, you can choose the different, you can choose the respective job, and then you can start your track survey. It's all icon-based. Cannot show too much detail, but here you get a little glimpse of how the track surveys look, with all information on one single display. Once it's done. The survey, you leave basically the track mode, and you're back into your office mode, where you then start analyzing the measured data, comparing with the design data. You do evaluation, and what else you do with it, we're going to see in the next section. So here, Amberg tamping. It is a high performance tamping survey. It is a full suite to do tamping jobs in various configurations, depending on what are the needs. The problem today is, if I remember like 10, 15 years ago, I had a train every hour from Zurich to Bern in Switzerland. Today is every half an hour. And the trains don't run only till 11 o'clock at night. No, they run till 2 o'clock at night. And of course, in the morning, the early birds want to catch a train at 5:30, preferably. So you see the gaps where you can actually perform track maintenance is getting smaller and smaller. Plus the abuse or use, I could also say abuse, of the tracks and the rail today are much more severe, much more intense than they used to be 10, 15 years ago. So we need systems to comply with these short time windows to do maintenance. So Amberg has developed a system which can gradually grow with this kind of demands. So it is a tamping system consisting of, it's a scalable functionality matching the project and the budget. Sometimes it's no need to have an IMU because you have enough time. If you don't have time, you will most probably need an IMU to increase your productivity. It's easy and powerful. It is done for the people on the track. It's not done for surveyors, so they can easily do this tamping. It has, like I said here, geodetic precision without geodetic skills. You don't need that. It's done for the track workers. It's solid ruggedized, and it has been proven, like I mentioned, for over 20 years. The system has been in operation. We're selling it all over the world, and we are the leader in that niche. So different applications. I mean, you have a tamping job, but of course, when do you need that? You need that for renovation, ballast bed cleaning. You need during construction and maintenance. You want to compare between the as-built, how does the track lie here today, and the design, how was it 3 years ago? Yeah. And do we need to do some, are we still within the specs? Do we need to do some tamping or not? You don't necessarily have to produce tamping as long as you're still within the limits. You can then still compare to design or previously taken measurements, which would be the reference for today's as-built. And of course, track geometry inspection, etc. Inspection of platforms and narrow spaces can all be done with the very same application called Amberg tamping. And of course, you can also do control points at the same time. You can inspect the quality of your control points. How does it look? Here, I just give you a quick example of 3 different configurations. 3 different configurations, starting with the basic one, the GRP 1000, which in connection with an Amberg, with the Leica total station, will give you that would be then, of course, a geodetic survey compared to a track survey. It is a geodetic survey using a total station in a basic configuration. Then we have a long chord measuring system, which we still offer, though we don't sell it much anymore these days because we have the IMS, an inertial measuring unit, where you only need one person. The biggest difference here, you can see different configurations. Of course, it will be a different application. Still the same trolley, still the same base. The difference is here. You can see the performance. It's about performance of the track. Like I said, if you have not a big window at night to do a track survey, if you have to maintain a piece of ballasted track within 4 or 5 hours, you rather you do it in one night and using an IMS than have it in 5 nights using only a GRP. But again, it comes to what are the requirements, what is the budget, etc. So these are the different systems you can use for the application tamping, and that's the configuration you would require to perform this tamping application. This is a new system which we are offering. It is one system. It's a high performance tamping survey with an IMU. You see here, I just go quickly through what it gives you, what possibilities. We have 2 different IMUs, a small one, a little black box. That's a real black box here. And the more performing one, you can see the different sections. You can do up to 200 meter, 300 meter with the bigger one, and only 120 meter, bearing the same accuracy, of course. Yeah, always talking about precision as well. You can add control point measuring devices, either it's a profiler or a total station, and then it will call IMS 3000. That's technical, don't want to go too much detail. And of course, it has a battery system for 10 hours autonomy. And of course, like I mentioned, it's always in connection with the respective software for the respective job you need to do. In this case, would be a tamping job. Important again, I can't not emphasize, it is about performance. Here, with this kind of configuration, we can typically do between 2,500 and 3,500 per hour. It can go up to 5 kilometers, but then everything needs to be extremely a perfect team, and everything needs to be perfect. We rather say somewhere between 2.5 and 3 kilometers per hour. So if you have a 5-hour gap at night, you can say we can do around 10, 12 kilometers stretch in one night shift. So here quickly, just a little overview of our IMU family. We started in 2012. We were the first one offering an IMU on the track measurements. Important, an IMU is also very, very important when you have to do, we cannot do any geodetic measurements, for example, in the Middle East. You have, during the day, you have too much refraction, so you would lose connection between the prism and the total station, and IMU solves that problem, yeah? So in 2012, in the Middle East, they were doing a lot of track works, laying new tracks, and they had big issues with the refraction, so the IMU was very helpful for them at the time. And of course, today we are offering the IMU or AMU, the Amberg measuring unit, the IMU 2030 and the 2010. Don't want to go into too much details, but these are our offerings today. Just a quick, what is the difference here? We have here quickly a comparison between the 2010 and the 2030. Here you can see with the 2030, up to that point, we have the same accuracy, then we lose accuracy, but for the same accuracy, we gain performance when we use the 2030 IMU. Just to give you a little bit of graphical understanding what we mean by getting more performance out of it. Here, just graphical as well. Repeatability on 60 meter, we get the same with the big IMU on 210 meter. That is important when you don't have a highly dense control point network along the track. So that could help you to overcome that as well. After you've done all your track works, then you go back. You have your you change from the field mode into office mode, and here we go. Then we start evaluating here. Here you have the chainage of your track. You see what was deviated, and that's the correction value. Don't want to go into much detail here. Here, a bit more in detail. You see, we do basically the contrary. We have to correct the track. You see here, that's the horizontal alignment. You see where it could be. You have the central line, and these are the thresholds, the dotted lines. And you see, we basically do a mirror for the tamping machine. Once it's done, all is evaluated. You create the data, and you export that to the machines. As you can see here, we work with all major tamping machine manufacturers, plus Toyer, of course, the #1, the leading in the world, with their various control systems. So we can adapt very simple and have adapted to machines, and then we can simply export that through a USB stick. Usually on site, you do in front of the machine, you do the as-built, you compare that with your design, and correct to calculate the correction factors and values and hand it over to the machine. Machine does its job, and you do a survey behind the machine to confirm that everything has been done, hopefully in one run. Otherwise, the machine has to do a second run. That was it for the tamping. Now, Amberg inspection. It is for track geometry. We want to understand, how does my track look like? So this is track geometry. The system, you see a very basic configuration. Again, the trolley with the 3 sensors, odometer, cant, and gauge sensor. And in this case, we have a so-called an IMU. This is a relative measurement system. It offers full productivity from day one. You know, it's robust. I don't want to go too many details. One-man operation. That's super cool. You don't need 2 people because you don't have it's a track-based system. It's not a geodetic system. So you don't need to have a total station which follows the trolley. It's a very simple process. Of course, yeah, don't want to need measurement relevant track geometry, quality precision according to the European standards, the 13848-4. And of course, it is flexible. It can export the data, etc., etc. For us, it is a basic information to get how does my track look like. That's about Amberg inspection. Then the next will be Amberg survey. Now, in survey, there's a big mistake on that image. You can see this gentleman, my colleague, doesn't wear a helmet. So always wear a helmet like my other 2 colleagues here. A helmet needs to be worn on a track, but sometimes for purpose, they forget, for big picture taking purposes, they forget to put on the helmet. But basically, that's the way you have to look on the track. Yellow or orange, depends a little bit on the country. If you go to the Netherlands, it has to be yellow. Orange is not allowed, but that's a little detail. So as-built route, we have a system configuration here. You can use, when you want to do the 3D track surveys, you can either use control point or GNSS-based track survey. Needless to say that the GNSS would never be as accurate as a control point, but it is a start. When you want to have a track information, a 3D track information, you can use GNSS. It's easy workflow. Like I said, it's made for the track workers, and you don't need to be a surveyor. Yeah, high output and low traffic. You don't have impact on traffic. Yeah, it's again. I don't want to go in too much detail. It's very comprehensive. You can do much more than just just track works or track survey. You can also set up control points. You can intensify your control points network while you do your track assessment. Typical configurations here, they look similar. As you can see, they look similar. Again, the configuration doesn't necessarily describe what kind of application can be run. On the same time, you can see you can have, with one configuration, you can run different applications. As we saw before, you can do a basic inspection. You can do now here a survey with this kind of configuration, and you'll see later the same configuration can be used to lay slab track. So the configuration does not necessarily tell you what you can do with. You can do a lot with several, with one configuration, you can do up to 3 different jobs. Yeah. So here again, we're talking, I'm not going too much detail. We're talking here, we're talking about productivity, yeah. Here, that's a result. This is kind of an inventory data you get. As needless to say, you can take any annotation, you can take any point along the track. You can measure an encroachment. You can say, oh, what is this? The platform edge, or I have here a box with electric box wiring, etc. A bracket. I can stop the trolley, aim my total station or my laser pointer to it, measure it, and enter a text what exactly it is. It will carry the stationing, it will carry the 3D data, the 3D information of that point you've just measured, and then you can just refer that and have that back in your analysis. So you get a total inventory, what lies around your track. And you can see we have different export, land XML, DXF, ASCII. So for us, for you, it is very, very flexible. It does not only it's not only track itself, but here, for example, you can see here, you have a point, different points, and you have the 3D information, and then your remarks. What does that mean? That's T mark on a concrete mast here, and it says all little details. This you're free to enter any text. So it gives you total inventory along the track, plus, of course, all the track information. After the survey, of course, we go to the top notch here. It is Amberg clearance. It's for mapping and clearance gauging, of course. Here you see a good example. And like I mentioned, in most tunnels, like you have in the follow line, you have slab track. Yeah, you see this is the new tunnel. And obviously, this is an older tunnel which had ballasted tracks in it at the time. That tunnel, can't exactly know which one. I think it's somewhere in Germany, but you can see that's the old days. These are the new days using slab track, and have to make sure everything is fine for a safe passage of the train. So these guys doing a fantastic job. Again, these guys not as fantastic. They're not wearing helmet, but I've mentioned that. Don't want to read all details. But it's a scalable system with different scanners, as I will show you right now. Yeah, the data important as well. These scans can also be used for tunnel inspections afterwards, which have nothing to do with the track. Basic job in Amberg clearance is really to see if I have a proper clearance for a safe passage of the train at different envelopes. So inventory scanning can be done as well. Single trolley configuration, and you can do referencing with a tachymeter or with an IMU unit. You can do the registration later on using black and white targets, which you pick up along the track, etc. So you have full flexibility. So it's consisting of, again, the trolley. It's different scanners. I'll come to that. We have different scanners you can go for. And of course the IMU, smaller ones, and the high performance one. And of course, even GNSS if needed. If you don't, of course, people go like, oh, in a tunnel, you cannot do GNSS. Yes, but here in an environment like here, when you're in the outdoor and you want to control at the station, the platform edge, etc., the edge of the roof, you still have GNSS operations possible, and using a scanner to do all the clearance job. And of course, the battery is about for 8 hours. It's quite a high performance battery here. The battery on the lower end, sitting on the trolley. Needless to say, for night operations, we have integrated lighting, etc., etc. And of course, again, at this configuration, you would need the clearance mapping software, which runs here. That's the configurations. Again, we call it GRP 5000. 5000 always will mean clearance, will always mean there is some sort of scanner on top of the trolley. I'll come to the next slide. I'll show you the different scanners. Here again, performance. and whatever is needed from the customer. I don't want to go too much detail of all these configuration, because it can be troublesome if you see how flexible and how various configurations you can do with our trolleys. Here, that's the offering we have, the 3 scanners offering. The biggest difference is that I have a mistake on this one. Don't know if someone recognized that. Here, this one has only 320. The imager has only 320 visibility. So you won't see the ballast. You won't see between the 2 rails. Though, on the other hand, you can use it on the tripod. So we have a lot of customers using existing HDS 6000, 7000 from ZNF, or Imager 5016, old ones from ZNF. They can also use it as a tripod standalone mode. If you want to see between the tracks, you want to see the ballast, you want to see the writing, you want to identify the safety devices between the tracks, you would rather go for a scanner which has a visibility of 360. This is not a scanner, we call it profiler in this case. And here we have 2 offerings. They're both not Amberg scanners. We don't produce scanners. We are a software company, of course. This are the ZNF scanners, and with the latest development here, important is the rotation speed is quite immense here, 267 rotation per second. So you pick up an enormous amount of information, and each second you produce 1.1 million points at a very good accuracy. So it is a choice you have to make. What does it require? What kind of information do you want to get off the track? So these are different possibilities. Yes, the middle one is really a heavy one. I mean, that's basically the successor. You see the weight is quite important. It's double the weight, yeah. Here, that's a typical application, a profiler 612 with an IMU, with the older IMU at the time. In the newer system, there will be less cabling. These are rather old images. Here, nicely to see, this is the scanner with a visible red laser. I'm going back quickly here. This scanner can offer a visible laser. All the others are invisible laser. Sometimes you want to know where am I exactly measuring? So you could opt for the M version of that 6012 M scanner, where you can see where your scanner is, yeah. And here it just gives you information. These are kind of results you get out of it. You get a real-time information on encroachments. So you get a real-time visualization of your profile. You select, you set up your envelope according to your rolling stock, of course, and the tolerances you have, and it gives you exactly information at each stationing. It's online. This as long as you move on the track, these things will change constantly. It will give you information, encroachments. There are several ways to do it. The continuous, in stop and go versions, etc., etc. These are the visualization then later on. And it can give you then exactly at which stationing you have to be careful. Here, there's a little one that will indicate in red that something will endanger the safe passage of the train. Of course, we're working also on an analysis object, the railhead, for example. These are kind of results you can get out. Most important for the people today are, of course, track platform edges, and of course, tunnel railhead in analysis, platform analysis. These are all information you can then extract from the generated point clouds. Here's a nice visibility. And here, for example, that would be a typical application using additionally a GNSS if you don't have enough control points to bridge the control point gaps, to have a GNSS, at least that you have a 3D information along the track while still scanning. Here, you have then, for example, identifying I call it the fixing point of the track, of the rail, etc., etc. That's a top view. So yeah, our software can do all of this kind of operations, all kind of job. Just a few screenshots what you can achieve with this kind of setup. Of course, it requires a bit knowledge how to use it, how to set up, and then to interpret the data properly. But it's quite amazing what you can get out of the information of just one passage. Not only have the track, how it lays the track, but how it's relative to the platform edge or to the tunnel walls. Yeah. Here, these are then results which then can be exported into a BIM, so retro BIM and the as-built. You can export, exchange the data in the PTS, LAS files, etc., etc. So these are all the possibilities based on the data acquisition in a tunnel with Amberg GRP or IMS 5000 clearance. So we leave it a clearance and we go slapjack. As you have in the follow line, slapjack, like I said, it is for measuring data, to lay the tracks, and of course to analyze or to do as-builds of tracks. Here, a typical application. You see here the basic configuration of our trolley with the simple prism column and the prism, which is tracked by a total station from Leica, preferably 1 second, even better, half-second instruments, of course. And you can see here this little antenna. So the total station sends his 3D information constantly to the trolley, which that will be processed with all the track information, within the track geometry information we get onto the computer. So everything is on one platform. So you can lay the tracks in various, you can lay the tracks in very simple way. And again, here, this is designed for the track workers and not for surveyors, yeah? And you can see here, when you get the absolute accuracy during the construction time, etc., etc., yeah? Here, that's the application you can do with an IMS or a GRP. Again, here, you see performance. It's about performance. The moment you see an IMS, you can check the performance. Yeah, an IMS, of course, has a very much higher performance than if you do it in a geodetics in a standard way. You can barely see the total station, like a total station here, which I say communicates, locks onto the prism and sends its trajectory, his position information through the little antenna here to the system. So they're constantly in communication. But as a principle, you see, you would always need to relocate the total station, do a resection, and then lock on the prism and then continue working. So that's a more tedious work, but it does the job. Maybe not as critical in construction. It's more critical performance when you have a live track and you don't get much time on. You don't get much track time. Yeah. So here, just a quick insight when you do track works, like I said, configuration, slapjack construction, 12 hours, you can work 12 hours. Like I said, we prefer, or you should prefer 1 second or even half-second instruments. If you buy half-second instruments, of course, you make Leica happy. They sell a high-performance total station with a high accuracy. Yeah, here just some as-built assessments afterwards, and it's nicely indicated the moment in a tabular version, at the moment, or in a graphical version, the places you have your chainage here, and you see exactly where you have not met the requirements, so you have to go back and do reassessment, shimming, etc., etc. Yeah, I have found one example interesting in Norway. The follow line, I know, was laid by an Italian contractor. He brought the Amberg trolley and did that. It was, you can find that on the internet. Nice picture of that follow line. I remember I've sold once the GRP 5000 to Oslo Tunnelbane or Metro. I call it Metro. I think it's Tunnelbane. Don't exactly know what happens to that. And somewhere we sold also a at the GRP 1000, it's difficult to understand where exactly what happened with those trolleys these days. But here is an example, which was also, give you a quick example. I don't have much of it. It was the Oslo-Drammen and Thun-Lirasen. These are, unfortunately, I don't have the details. It's all in German. So what they did, of course, they had to intensify the Festpunktverdichtung. They have to the control point density. They have to increase the control point density, etc., etc. Did all the work, and of course for BA-Nettverket have to develop. They did also the whole ballast track, etc., etc. Here's some examples, some images. They had to do some comparison. They need to have as-built, and of course, then they did some renewal job. That was a company from Germany who did that job sometime in. I don't have any idea information on when this was done. Here's some impressions of how it looked from that Lirasen tunnel. You see here, ballasted track in the tunnel. It's kind of noisy and dusty thing, yeah. Here are some other examples comparing to do comparison to the platform edge, etc., etc. So this was a job. Here a nice view how it looks when everything was finished, and all the reports which were then supplied to BA-Nettverket. So I have now, yeah, I'm absolutely good in time. So what is our value proposition for the better track performance with the Amberg Rail system? What are the benefits? It's an all-in-one platform. It's a one source-based information. Any of the application I just showed you, if it's inspection, if it's tamping, if it's slab traffic, it's clearance, it's always the very, very same platform. It's called Amberg Rail 3.0. So all-in-one platform, one voice source, you're minimizing errors in the fields. You don't juggle data from one application to another. You don't have to go from one computer to another. No, you basically stay everything on the same computer. It's efficient workflows. It's time saving. You have instant feedback. You get an instant analysis. You have a real-time information on the track. And if you are a contractor doing such track works, it gives you a competitive advantage because the workflow is absolutely seamlessly, and it gives you competitive advantage for the next bid you hand in. It's user friendly. It's built for track people. Yeah, you can make economies on expensive stuff. You don't need to have a surveyor like in the old days where you do everything manually. You have to make sure you really measure things properly. You know, when we're talking high speed, which you don't have yet in Norway, we're talking high speed tracks, 250, 300 plus. In China, all the tracks are laid, I think, between 350 and 400 kilometers an hour. So we're talking millimeter accuracy in all three dimensions, in northing, easting, and height. So all these over the cant and etc. It needs to be extremely precisely laid. So there we can do that without a contractor, without the survey on the track. The staff, the track people can do that and can achieve the required accuracy easily. It's like I said, I mentioned it already. It's real-time processing. It's a seamless workflow, and it will reduce your production cost. Yeah, and of course, it grows with your requirement. You know, you can start very simple. Tomorrow I can then do another job. So your investment is protected because everything is based on the very same trolley. You just add new sensors on top. You complement the sensors then with the software applications, which is a simple license. You activate that license in Amberg Rail in order to be able to perform a tamping job or a survey job, whatever needed. Yeah, and that for us, for you, the benefit is it's a fast return on investment because your investment is protected. You're always using the same trolley. And of course, we have over 20 years of experience. We're the leader in our niche, and we're complying with our today's standard, which I mentioned you, that 14838 EN standard. Yeah. So to conclude, we have a success story since 2002. We have a system which is very modular, scalable. You can upgrade it. It's proven. It's specialized for track and track works. Yeah. We have the platform, the hardware platform, the GRP system, on which you then, depending on the configuration and depending on the job you need to do, you work with this respective application. And of course, we constantly strive for new applications, for future applications, always based on the same trolley, because you will always need a cant, gauge, and an odometer, these basic information on your track. They will always be needed when you do professionally track works. Yeah. And that's basically concluding my presentation. I hope I was not too fast. I hope I didn't overwhelm you too much. Here is our contact if you would like to have more information. Yeah. Yeah, that's it from my side. Are there any questions? I stop sharing my display if I manage. Yeah. Oh, there was someone has a question here, it seems to me.
Thank you very much, Philippe. I must admit, I was a bit overwhelmed, yes.
Sorry, Inger.
But I have a few questions, and I hope other also have some questions. Please use the chat or Norwegian, and I hope Joel can translate. And you mentioned a few Norwegian projects, Follow Banen, Follow Lane, I think you called it, and Drammen, Lieråsen. But
I have worked with that project with Lieråsen.
Nå er det en som sier noe her, er det Henning?
Ja, det er Henning her.
Vil du skru på kameraet ditt, Henning?
Jeg kan skru på.
Oh, hello, Henning.
Hello.
Hey.
I work with this Lieråsen tunnel and the platform. You have a picture from the gap to the platform. Yeah, so I know it was interesting. We have a little problem with the gap there to the existing platform. I have the track, the rail plan.
So you have to adapt the track. I mean, track gap it's a kind of a two-sided sword. You know, you want to be as close as possible for all the handicap. You know, on the other hand, you don't want to be too close that with the various load of the rolling stock that you would eventually touch. You know, if you look, you go to T-Bahn or any metro, it's quite amazing how close they drive to the edge. Yes. So in your case, what was you had to do?
We should keep the existing platform.
You want to have an as-built of the existing platform?
Yeah, have the new track, but the existing platform. But the existing platform don't have the needed tolerance.
So you replace the track, and you wanted to make sure that the track relative to the platform stays within the envelope of the rolling stock. Yeah.
Yes.
Okay. Interesting.
But
and
did you use this Amberg Rail, Henning?
I didn't use it, but the Bananur and
the company Spitzke was there. It's a German company who did the job, yeah, at the time. Yeah. Okay. They used Amberg, yeah. Spitzke used Amberg for many years.
I have to use. We have the problem with the platform because it was a gap. What do you say? In one point, it extends 5 centimeters.
Okay. Yeah.
So it's a big problem.
It's a challenge, I would say. Yeah, if all of a sudden it's yeah. And that's
So
classic
you have to do
application.
we have to do some things on the platform now.
Oh, you have to cut off the platform. Yeah.
Cut it a bit.
Yeah. Okay. Are there any other questions?
Det hørtes ut som det var noen bak som snakket, men det kanskje bare var. Is this, do you buy this thing or do you use companies like Spitz, et eller annet?
I mean, we as Amberg, we're Amberg Technology, we are selling these components. We're selling these components to companies like Spitzke. We're selling these to companies like Skanska, companies who specialized offering services into the rail market. If it's not done, for example, in France, SNCF, the National Railway of France, they're doing themselves. They have 35 GRP 5000, IMS 5000 trolleys. So they do all the track works themselves. They do all the track works themselves. So it depends how a country, the track is who does the track work it depends how a country is organized or a national railway is organized. If they outsource everything, if they have their own team, so either it could be the Norwegian railway company, which is called now what is it called? BA-Nettverket would be our customer, or it would be clients, customers like I mentioned, Spitzke they come from Germany, bring all the material and execute that job, which was done there in Drammen. Yeah.
It could be interesting, for example, for BA service in Norway, which carries out some of these works.
Absolutely. Yeah. I still don't understand how the track maintenance is done in Norway. Who is doing that? Is it are they using different instruments? Yeah, or is it done manually, or how frequently is on? I have not much information. Maybe it would be interesting to understand that from BA-Nettverket how it frequently it's done, what are the prerequisites, etc., how it is done today.
Is it, who do the maintenance? Is it BA-Nettverket or is it BA Service? Si det, svar gjerne på norsk. Kanskje ingen vil...
It's both actually. BA Service was previously a separate organization. Now they have been included back into BA-Nettverket system, so they are doing the day-to-day maintenance. The renewal is always put out to the market, and measurements is done by train from Mermek in Norway called Roger 1000. It's under own power, able to drive in 160 and pulled in 200 kilometers per hour. And we also have an additional other measurement wagon, which I don't remember the name of, which is a slower speed. Yeah, and these I think are IMU and laser based.
So then we're talking relative track maintenance. It's not, or is it?
Yeah, well, they do also have a GNSS system, but it's not the main position source. It's relative. So
okay.
So as many other administrators, we also have issues with the position of the measurements. It can drift from one year to another. Mostly we are basing the position on the odometer on the car, and it has some drift.
Yeah, odometer are a bit tricky because the odometer generally is on one wheel, you know, and if as long as you go straight, it's fine. But the moment you go in a curve, the inner rail, if the odometer is on the inner rail, it does less weight than the outer rail. So, you know, with an IMU, you can compensate that. Yeah, an IMU can compensate that, but because it records the trajectory. But in order to control this, you need to have control points to tighten the trajectory of the IMU, because an IMU has a drift. You have to tighten that back to a control point. But I mean, there are so many tracks, thousands of kilometers of tracks out in the world which are laying there in relative, because there's no control point network, and the GPS gives you a bit of hint where they are. But you don't actually need to have 3D information. But the moment you get into a city area where it's a bit more condensed, then you would need to have a 3D information. Yeah, the trend goes more and more to 3D track application, of course.
I see your equipment and our measurement wagon has two different applications. We are doing it for maintaining the operations, and your equipment is more for production and renewal and new projects.
You are now Häggborg, okay.
Yeah.
Okay. It's difficult to see. And you're from which company?
Yeah, I'm from BA-Nettverket. I'm a geologist, actually, so it's not entirely my field, but I work with systematic maintenance as well.
Okay, perfect. Thank you. It's just understand, yeah.
I need to thank you, Eivind. I need to ask Joel something in Norwegian. Is it okay with you, Philippe?
Of course, I will understand anyway.
Jeg er ikke sikker på om jeg har forstått alt. Yes, altså Amberg Rail kan brukes for å bygge nytt. Og så snakker han om maintenance, altså vedlikehold, og da ser jeg for meg at da har man ikke noe land XML, da har man ikke noe data kanskje for sporet i det hele tatt.
Ja, det man gjør i dette tilfellet at man tar opp spor før, man sjekker hvis den ligger hvor den skal. Men hvis man finner ut at den ikke ligger hvor den skal, da kommer det disse store maskiner som han hadde på bildet av de tampingmaskinene, som tar opp spor og legger det på nytt. Og da kjører man foran, man sjekker hvordan det står foran, og man sjekker rett etter denne maskinen også for å bekrefte at sporet deretter ligger hvor den skal ligge.
Aha, nå det noe i chatten.
In chat, I just put a link to the wagon we use.
Thank you very much. Got it.
Jeg vet ikke hvis det var klar for deg, eller?
Ja. Jeg lurte jo på en ting til også. Altså, eller to ting. Men for all del, andre må spørre, ikke bare jeg, og spør gjerne på norsk. Joel oversetter, og jeg synes det så ut som det var mye utstyr. That's a lot of things. You need to buy, or is it possible to rent, or and do you have a showroom? Do you have some? Can I travel somewhere to see how this works?
Yes, you can come to Switzerland.
Yes.
We have beautiful weather today, so it'd be a perfect day to give you a demo. We have our track just next to the company. We have a live track where trains run. It's an industrial track. It's not so frequently, but we can demo you most of the things there. We can demonstrate. We don't have a showroom as such. We're not a walk in and walk out company because we're talking some money here, you know. So yes, you can come. We can also do demos. If a customer is seriously interested. Mostly the people come to our place because here we have everything. We can show everything, and we can, of the various configurations, we can show you how to set up a project, etc., etc. First question, no, we do not rent. Rent, that's not our business model. If you absolutely want, I think we surely could offer you a price, but most probably the price will shock you because it's not our business model. Yeah, we are selling because it's not a one-off. You just say, oh, and do that little 1 kilometer stretch and off I go. Yeah, because I would need to train you, and you would have to pay for the training as well. You know, so normally companies, they come, they have an exact idea what they need to do, and they buy a basic application, for example, let's say a survey or an inspection, and then we gave them the training, and they thought, oh, now we want a job to lay a tamping, to lay a slab track. They will add the software. We'll teach them how to use the software, and that's the way it works. Yeah. So if somebody buys that, he use it frequently. You use it on a frequently basis. So the investment returns, pays off. Yeah. If you don't want to buy it, then we would recommend you company like Spitzke, like Leonhard Weiss, or other companies who have our trolley and can offer you the service.
Yeah. The time is 13:07 past 1. And there's time for one more question, I think. I personally would like Eivind to repeat what he said in Norwegian, but maybe not now. I can ask him afterwards, because I didn't hear or understand everything. But I can ask you afterwards, Eivind, or another day. Yeah, there's no more questions. And then I only say thank you very much to Joel and Philippe. And I hope I can get the PowerPoint, the presentation also, Philippe.
Yes.
So I'll put into the program and into the Meet the Outlook invitation. Yep. So, and we'll send you all a link to the recording for today. And I hope there's a lot of questions and you will talk together afterwards. So I'll just say thank you. And I hope we'll see some of you again on the 20th of April at Fornebu and a tunnel conference then. Okay, yes. Thank you very much.
Tusen takk, Inge and Joel and everyone attending and standing by for that lunch presentation. Thank you very much.
Thank you very much. Thank you very much.
Thank you. Bye.
Ha det bra.
Ha det bra.
Ha det.